Yeah.
and we have 4 designers, and we have 4 projects. The idea here is that uh, we have the quality score given for each designer for each project. So the value 90 here means that when designer do project 1, the quality here is 90 over 100 or 9 over 10, which is very good. Remember that this is high quality, this is quality score, so the higher the value the better, right? So for designer 1, he or she works best in project 1. For designer 2, the highest quality score is for project 2, etc. Okay? So remember that there's a quality score for each designer for a given project. And for question 1, we have to assume that one designer is assigned to each project. So if there are 4 projects and we have 4 designers, we want each designer to be in charge of one project. And we want to allocate the project to designers such that the quality score here will be maximized. Okay, so those are the questions that we need to do. So if we have the information about the second activities in this, summarized in this table over here. Now we'll just use solver to deal with these problems. So we have a project like this, and now we have to we'll just copy this table here up to here. Okay. Now we'll just delete everything. We do not need the tab here. We just want to maximize the quality score here in this case. So again, we'll just assign 0 here first because we have no idea which designer should be in charge of which project. So we'll just do it like this. And then we'll just copy everything here from activity number 1. Now the reason I can just copy the file here is because for both questions, for both activities, we have 4 columns and we also have 4 rows. If the columns and the rows are different, then we should try to adjust the value a little bit. Now for this, we'll just double click on this to check whether the calculation for this should be correct or not. So it seems that everything is correct now. And the constraint here is the same. We say that for this activity, 0 here means no participation, and 1 here means participation. The constraint here is that there is a constraint here. One designer is assigned to one project. So I'm going to copy the constraint in here. So one designer is assigned to only one project. That is the first condition. The second condition here is that for one project will has only one designer. Now this is to eliminate the case where we assign 2 different designers to the same project, which is inefficient. Okay, and the decision variable has to be binary, 0 or 1. Obviously 0 for no participation and 1 for participation. Right, so those are the constraints for this problem. So basically they are the same constraint as before. And then we go to solver. Sorry, we have to set our objective here. So I will select this. Let's just paste it here. And in this case, we want to maximize the quality score, and we'll just check this. It's still a little bit different, so we need to change this one. Right. So we'll just take the sum product of the score, quality score, together with the projects in which the designer is in charge. So for example, if our project designer 1 is in charge of project 1, then it means that all other projects will be 0, and the quality score will be 90. And then we take the sum product of this to like this. And now we're just building silver. We will maximize the quality score. Remember that in this situation we might have to maximize the score by changing our antecedent variables here. And again, those variables here must be binary, and there are several conditions that we need to satisfy here. Okay. So we have already found a solution here. And then we have the score. The maximum score here is like 315, and this would be done when designer 1 is assigned project 1, designer 2 is assigned project 2, designer 3 project 3, and designer 4 project 4. Okay, so we just double check this. For example, for designer 1, if he or she works back in project 1, so it should be given project 1. For designer 2, the highest score is for project 2 also. So just an assessor. Okay. So the maximum score is 315. Right. So that is the first situation. So I just rename this one to activity 2A. And now I'm going to duplicate, copy this activity 2A here. I just put a copy. And I will just rename this one to activity 2B. Okay. So we have activity 2A like this, and we have activity 2B now. Now for activity 2B, the question is now different. Each designer have 80 hours available, so we have another limit here. In question 1, we do not have the limit on the number of hours each designer can work, but for the second question, we have another constraint, which is the number of hours available for each designer. And now the assumption also changes. More than one designer can work on one project. So for example, for project 1, we can have like designer 1, designer 2, and designer 3 work on the same project 1. Okay? So that is a change in our assumption. The objective is the same. We want to maximize the score, but the constraints have been changed. So how can we do this? So let's just come back to this one. No, we will not use a constraint for this one like this anymore, because now one project can be in charge of like more than one designer. So first I just set this one here equal to 0 first. Okay, I'll just bring it back to normal. So we do not have any binary situation here, means 0 or 1 here. We'll just take what we call the percentage of participation. And the percentage of participation here will be from 0 to 1. Okay? Or it can be 0% to 100%. Okay? So it means that for one project, designer 1, for example, would contribute 50%, designer 2 would contribute 30%, and designer 4 would contribute the last 20%. As long as the project is finished, then we don't care how many designers will be involved in the project. Okay? So we just calculate the percentage of participation of each designer in the project. So designer 1 can participate like 30% of project 1, 20% of project 2, and 50% of project 4, for example. As long as project 1, 2, 3, and 4 are all completed. And as long as the working hour of each designer will be less than or equal to 80 hours, which is the maximum, working hours here for each. So the condition here is now has been changed. It should be smaller or equal for each designer here. For each designer. The constraint here will be now the number of working hours will be less than 80. So I will just change the values here, 80 here first. And the result here is no longer whether the designer participate or do not participate in a particular project. The results here must reflect the number of working hours for each designer. So how can we do this? We will just say that okay. Let's say for example, designer 1 here contribute 50% of project 1 and 50% of project 2. Project 1 here takes 30 hours. Remember that time here is an hours. And it's just the time it takes to complete the project. So for project 1 it takes 70 hours to finish. For project 2, 50 hours. For project 3, 85, and for project 4, 35. So if designer 1 here is in charge of 50% of project 1, it means that designer 1 will have to spend 35 hours, or 50% multiplied with 70. Okay, to include that, to say that okay, designer 1 has to spend 35 hours to complete 50% of project 1. And if designer 1 also join in like 50% of project 2, then 50% of project 2 must be 25 hours. So in order to calculate the number of hours each designer would work on the project, we are going to use the sum product function. And we take the percentage of participation for each designer, multiply with the time it takes for each project to be completed. And we'll just fix this value over here. Okay. And that's represent the total hours, the total working hours for each designer in all of the projects. And we'll just do the same for each of the images autofill here. We can calculate the number of working hours for each designer, and that should be smaller than 80. So the first constraint here is that max working hours for each designer is 80. We do not have this anymore. The decision variables. The decision variable here can be any value between 0% and 100%. This is actually not a constraint, so I'll just explain it here. Okay. So the constraint here is the maximum working hour is 80. And the second constraint here is that all projects must be completed. Okay, so in order for all projects to be completed, we just take the same. The sum of the percentage participation here for each project must be 100%. So we just set this one to 100%. Okay. So I don't care whether designer 1 For example, designer 1 50%, designer 2 20%, designer 4 30%. But the total here must be equal to 100 to make sure that the project is completed. Okay. So those are the two conditions here, and we do not have the binary condition. And we can just let our values here, the decision variable here, to be any value between 0 and 1. Okay. So after we do this, we'll just double check this one, similarly to this, to the previous problem, and we solve this. Actually, the objective is the same, but the only thing that changed here is our, our constraint. We want to maximize this by changing this variable over here. We do not need the binary thing. I'll just reset. So we just click on this maximum value, changing those value over here, and we add the result here, smaller or equal to 80, and the sum here equal to the constraint here. And then we click OK. For this, we just click OK, and we found the solution, and you click it. So we'll just convert this one into percentage, so that it will be easier for us to see. Here. So designer 1 will complete the whole project 100%. And after that is will contribute 20% of project 2. Now the reason why designer 1 is assigned 100% of project 1 is because of this high score. And for project 1 here is only has like 70 hours. So still there is 10 hours left. So 20% of 50 here is another 10 hours. So designer 1 has to work 80 hours. Designer 2 will work 80% on project 2 only. So only work 40 hours. Designer 3 will work on 53% of project 3 and all project 4. For the total number of working hours here is 80. And for designer 4, he or she will only work on project 3 47%, 40 hours. Okay. So you will see from here that designer 1 and designer 3 have to work a lot, because they actually have quite high score in project 1 and 2 and project 3 and 4, okay, as compared to the other designers. Right. And the total maximum score here is this much. Okay. So this is how you do question 2. Okay. Now I want you now to